Alright, continuing on with 7.3. This is B, the second video, and we're in compound inequalities. And what we're going to do here is we're going to look at the union of a couple sets. Now, when we're talking about sets, they are either going to be unions or, I hope if I spelled it right, unions, sorry about my bad writing, or intersections. It's hard to write on an iPad. A union has the word or, and an intersection has the word and. So if you look at it as an intersection like this, alright, and you have numbers that are in here, that means that when you drive down this road, you're going to run over numbers going this way, and you're going to run over the same numbers going this way. So they work in both. They're at an intersection. You're going to run over road the same going this way as you are going this way. So they're intersection because they're included in both roads. Now, get rid of my pink. If we have an or, and I've got numbers here, and let's say I have numbers here, when I'm driving down this road, I'm going to run over these numbers, or if I'm driving down this one, I'm going to run over these numbers. I'm not going to go over both sets of numbers. It just depends on what direction. So if I'm on this road, I hit these red numbers. If I'm on this road, I hit the blue numbers, but I don't hit any of the red numbers when I'm on this road. So it's or. I'm going to hit either these numbers or these numbers, not both of them. So hopefully that kind of makes some sense as far as what intersection and union are. Intersection means there's commonality. Union means there's not. Alright, so if I have a graph like x is less than -1 or x is greater than or equal to 3, and I were to graph this, so that's -4 and that's +4. Alright, if I were to graph this, it does not include -1, so it would be round, and it's less than. So I would get an answer here for that. And if I'm looking at this one, I would start at 1, 2, 3 and be boxed because it does include 3. It's greater than or equal to, and because it's greater, it's this way. So notice there's no intersection. There are no numbers that work for both of these. I've got numbers here and I have numbers here. They don't intersect. There's nothing in common with those. So that's the way I would graph it. Now let's say I wanted to write this in interval notation. I write it as two separate ones. So I write this as -1 round and -infinity round. Okay, that's this right here. Then I write it, the next one, as square because it includes 3, and I go into positive infinity. Okay, and then because it has the word or there, I put this symbol. Kind of looks like a U or a horseshoe. It means union, and that's my answer there. I'm showing both graphs there and there, and because there's no intersection here, there's nothing in common, I get a U to show that there's nothing in common. Okay, and let's go ahead and look at an and inequality, one that's an intersection. Alright, so I've got an x is greater than -2 and x is less than 3. So when it says and, it means both of these are dependent on each other. Alright, so let's go ahead and graph this. I'm going to do it a little bit different than the book does. Okay, so there's my graph. Now let's graph the first one. X is greater than -2. So it's not, doesn't have any equality to it. some reason my pen isn't, there we go, negative 2, and if it's greater it's going to go this way, right? There's x is greater than negative 2. Now let's do, in blue, x is less than 3. So we have 1, 2, 3. Okay, we have that, and then we have a line that goes this way into infinity. Okay, what we're interested in is what these two have in common. What works for both this one and this one. And it's all the numbers in here where the blue and the red intersect. So my answer is going to be around, which is from here, around, which is from here, and then the number, negative 2 and positive 3. And you're done. It helps to make these graphs so that you can see what's going on there. Okay, because all you're doing is putting the symbol, the number, the symbol, the number. You know, the right hand side is going to be with this right, the left hand is going to be with this left, and that ends up being your number there. Okay, there is a shorter way of writing this. Whenever you've got and, you don't have to write two separate equations. You can write a compound inequality, meaning we take our x and put it there, and it says x is greater than negative 2. So notice I just switched these around, and it's also less than 3. So right there is the same as what we've got up there. X is between negative 2 and 3, and if you look here when we graphed it, it is. You can't do that for ORs. You can't do that for unions. You have to write it as two separate inequalities with the word OR there. But with AND, you can make a difference. Okay. So if I had an inequality that looked like this, negative 3 is less than or equal to x, which is less than or equal to 4, and I wanted to graph that, okay, I would do this part first. Negative 3 is less than, and I'm going to make a square because it says it can be equal to, that little line there. So x is greater, so it goes into infinity that way, and then I'm going to show x is less than 4, 1, 2, 3, 4, or equal to, and then I'm going to have my blue line that goes this way, and where they intersect is what I want for my answer. So my intersection is going to say open or squared off negative 3 squared off 4, and that ends up being my answer for this. This is called closed interval because both sides of those are included in my answer. They're squared off. If they were rounded like they were on the last one, it's called an open interval. Alright, so bottom of page 411 gives you the connection between the different interval notations and the line graphs there, so you can look at those to get an idea of what's going on. And I expect you to do that, have those in your notes, because those are going to be very important later on when you're trying to remember all of this information. Okay, so let's go ahead and do example number 5. And you'll notice there that it's a compound interval, or a compound inequality, so that means it's going to be an intersection or an AND. Okay, so what we're doing is solving. That means we're solving for x. Notice we have three parts to this. We have the negative 3, the 2x minus 5, and the 3. So what we're going to do here is we're going to solve this just like it's an x. Alright, so the way that we solve a compound inequality like this is, you know, when we're doing math, we're trying to get our x by itself. and we have a 2x minus 5 here. So what we're used to doing is adding 5 to both sides, but the problem is we have more than one side. We have this side here and this side here. So what do we add 5 to? You add 5 to both sides, this one and this one. So what we're going to do here is we're going to add 5, add 5, add 5. Okay? And then we do the same thing here. Divide by 2, divide by 2, divide by 2. And we get that. Okay, now we can graph it. Well, actually, we can write it in set notation first. And we can write it in, well, let's graph it first, then we'll write it in interval notation. We don't have any negative numbers here, so I won't worry about that. Alright, so let's go ahead and graph it, and I'm going to use a bigger pen here. Alright, so we're at 1, and 1 is less than or equal to x. So we have that, and then x is less than or equal to 4. We'll do that in red. 1, 2, 3, 4. And what we're interested in is what they have in common there, which means now I can write it in interval notation. Interval notation says I take my cool little interval signs and I just put my numbers there and there and there. And that's interval notation. Okay, let's do a couple more and we'll call it good. Alright, pen. And we'll do this. Is example 6. We're going to use OR, which means we can't put them together. Oops. Alright, they're saying solve the compound inequality. So we're going to do each one separate. Subtract 7 from both sides. Now remember, you can subtract 7 from both sides without changing the sign. It's only when you divide by a negative that you change the sign. Okay, so I get that. Or subtract 7 from both sides. Divide by 3. Okay, so I get those two options there. And let's go ahead and graph this. Well, first of all, let's write it in set notation. Set t such that t is less than or equal to negative 11 thirds, or t is greater than or equal to negative 1, parentheses. Alright, so that is in set builder notation. Let's go ahead and graph this. Okay, I'm going to make bigger pen, and I'm so sick of this pink color. I don't know why it always, yuck, that's just as bad. And that blue, it's nasty. I'd rather have a good solid blue. Okay, let's try it this way. So let's graph. And we'll finish this on the next video.